Welcome back, everybody. First video of the new year. I'm talking to the people at home because there's people that live stream my classes. That's a joke. That's not right. But yeah, first recording of the new year. You guys are all excited, right? Hype, ready to go. Let's go. Let's learn some algebra. Let's go, right? Excited. All right. Oh, okay. So, before we start actually into the coursework, the actual curriculum of algebra, what we're going to do is take a couple days and kind of dust off the cobwebs a little bit, kind of get our bearings a little bit, do some math, and then jump into the meat and potatoes of what algebra really is. Yeah, I use weird sayings like that. I have bad jokes. I have weird sayings. I'm sorry. But anyway, so what we've decided to do is take a couple of days right at the beginning here and talk about a couple of pre-algebra topics. So that's why you see pre-algebra on there. It's just a basic couple of topics that will kind of get our bearings, get us to do some math before we really get into some, like solving equations and whatnot, which is chapter 1. So the couple topics that we decided to do some notes on are order of operations, distributive property, and combining like terms and simplifying expressions. Okay. So what we're going to do here is take a couple of days. This is Wednesday, Thursday, Friday of pre-algebra material. Okay. Just kind of getting you ready to jump into everything, kind of dipping our toes in a little bit. So that's Wednesday, Thursday, Friday. Then on Monday, what we're going to do is kind of do like a half period of review over all those things, and then just have a really short assessment, really short quiz on Monday in the second half of class. I want to do because it's a quiz on a Monday, I want to do like a really good review right before we take the quiz on that Monday, okay? And you guys will feel pretty comfortable with it. Hopefully this is all review. Everything that we do this week should be review material that you learned probably in 7th and in 8th grade. I talked to Mr. Spottleston, Mr. Rutamus Hattinger. These are all things that you definitely know how to do. They've taught you. You should know how to do these things. So all this should be is a good review over a couple of different topics. All right. So the first thing we're going to talk about is order of operations. Order of operations. Now, when I say order of operations, my mind goes back to please excuse my dear Aunt Sally, because back when dinosaurs roamed the earth, when I was a little kid, that's what they taught me. Please excuse my dear Aunt Sally. Did you guys learn that? Yeah. Yeah. Okay, good. Because now everybody looks at me as PEMDAS. I'm like, well, that's just boring. Right? PEMDAS, okay, I get it, but that's not a word. Please excuse my dear Aunt Sally. It's just more fun. But order of operations, what does that mean in terms of PEMDAS? Well, P stands for parentheses. Okay. Now, what we're going to add into it now is parentheses, but not only parentheses, but grouping symbols. And grouping symbols which include brackets and radical signs and absolute value symbols and fraction bars and everything that we could possibly do. The second step would then be exponents. Now, jumping back to parentheses, make sure that if you've got grouping symbols inside other grouping symbols. So say you have like a parenthesis inside an absolute value symbol, you're working from the inside out. So you do the parenthesis, then the absolute value symbol. Maybe there are brackets, then parentheses. You do the parentheses first and then the brackets. Heck, what if there's a square root symbol and then a bracket, then a parenthesis? Well, then you keep working inside out. Parenthesis, then bracket, then square root. Then we would jump down to exponents. Once we've taken care of all grouping symbols, we would jump down to exponents. Now, what are exponents? Well, we're going to do whole chapters worth of exponents. Okay, we're going to talk a lot about exponents. But in terms of just numbers, it's just repeated multiplication. Like, for example, 4 squared would just be 4 times 4, right? 3 to the 3rd power would be 3 times 3 times 3. 4 to the 5th power would be 4 times 4 times 4 times 4 times 4, right? It's just repeated multiplication. That's what an exponent really is. We'll talk a little bit more about that later on. And then we come to multiplication and division. And now this is where people make their mistakes, and they should not make their mistakes. For example, M and D, just because in the mnemonic device that we use, PEMDAS, or please excuse my dear Aunt Sally, just because the M comes before the D does not mean that multiplication always comes before division. People always say that, oh, m comes before d, so they must come first. No, 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 no. Whatever, once you're all done with the previous steps, you use multiplication and division from left to right. That's really important. Go from left to right once it's all in the same line, okay? So if there is division on the left and then multiplication, then you got to perform the division first. Same thing with addition and subtraction. If you see if steps 1 through 3 are done, you got everything, and the only thing left over is addition and subtraction. You go from left to right with addition and subtraction. Addition always just doesn't, it's not like addition always comes before subtraction. You have to go from left to right. So now, we've got an expression here, and we're going to simplify, and we're going to show each step. Another reason why we decided to do order of operations and combining like terms and whatnot is because I really want to train you guys into knowing that in algebra, it's not always about the end result. It's about the work leading up to the end result. Okay. What I mean by that is, yeah, I bet you guys could probably just like plug this in your calculators and spit a number out to me. Whatever. But it's not about that. It's about, can you show the steps? Can you show the proper work to get to the final answer? Because guess what? If you spit out that number to me and it's wrong, where did you make your mistake? You don't know. Okay? You can't track it back. You can't go backward and see what happened. So when we do problems in our guided notes, I want it to look exactly like what I do on the board. If I put something in the board, it's written down in your papers, and I want the work to look exactly the same as well. Because when I go back to grade your tests and your quizzes, if the work doesn't look similar to what mine looked like, it's really hard to trace back. I love to give partial credit on quizzes and tests, but I can't give partial credit for things that I don't see. Okay? So show all your work, please. Now, 15 minus 2 times 3 plus 1. What should be the first thing that should happen here? Nathan.
2 times 3?
The 2 times 3, the multiplication, right? We don't see any parentheses or grouping symbols. We don't see any exponents. So the next thing that should happen is the multiplication or division. I see multiplication. 2 times 3. So I take my 2 times 3, and then I bring down everything that I don't use. I say 15 minus 2 times 3 is 6, and then plus 1. 15 minus 6 plus 1. See, now, this is where some people might say to me, oh, 6 plus 1, because addition comes before subtraction. No. No. I see addition and subtraction on the line. The subtraction must come first. I must take 15 minus 6 before I do the plus 1. Okay, I see addition and subtraction all on one line. I've got to take left to right 15 minus 6, which is 9, plus 1. Okay? Show every step, folks. Show every step. 9 plus 1 then gets us a 10. I always think for these order of operations and combining like terms and solving equations, your problems should look like an upside down triangle. Right? Your problems should look like you don't have to draw that, but you can if you want to. Your problem should look like an upside down triangle. You should funnel down, show all the work to get to your answer. Yes, Griffin.
Why is that 2 times 3 not negative 2 times 3?
Good question. Why is that 2 times 3 not negative 2 times 3? Well, if you treat that as a negative, it would come out to be negative 2 times 3 is a negative 6, right? You see the negative 6? So it technically is, we are technically doing negative 2 times 3, right? But in our case here, because that's just a minus sign, we can leave it alone. We use it as the operation and say 2 times 3 is just a positive 6. And just know that subtraction sign is going to carry through. We're saying the same thing. It mathematically means the same thing.
Okay.
That we're doing. Yeah. So if in your brain it works, negative 2 times 3, do that. Go for it. Because that's the same thing that I'm doing up here. Okay, questions on that one? Perfect. Let's go to the next one. 12 minus 3 squared plus 10 divided by 2. 12 minus 3 squared plus 10 divided by 2. All right, so what should the first thing that should happen here, Sid? Good. I perform the exponent. Good. I take the 3 squared and make it 9. So 12 minus 9 plus 10 divided by 2. Notice how I'm writing everything out. I know it seems tedious. I know it seems like I shouldn't need to write all that stuff out. No. You're going to find that in algebra, the more you show your work, the better you are. I promise you. Trust me. I've been doing this for a while. I know what I'm talking about. All right, what's the next thing? What's the next operation that we should do? We got Gio.
The 10 divided by 2.
Which is what?
5.
Good. 12 minus 9 plus 5. I perform the division next. I see only subtraction, addition, and division. So the division should come next. And then what?
12 minus 9.
Kyle, right? The 12 minus 9. Good, this is another one of those where I see addition and subtraction. So therefore I go left to right. I take the 12 minus 9. What do I get?
3.
3 and plus 5 will give me a final of 8. Okay. See it all funnel down to my answer? Algebra is a lot about showing the work, being very clear, being very neat, being very orderly with your work. Anybody still need that one? If I go too fast for you, if I slide down, I'm really sorry. I just get really excited to teach math. I get going. And so if you're like, hey, can you just go back to that? No problem. Just let me know. The nice thing is because I'm recording everything, if you do miss something in your guided notes or you like want to hear me explain it again, I mean, it's on YouTube. You can go back and rewatch anything I do. All right. Okay, now we have some grouping symbols in here, right? I've got negative 20 divided by bracket negative 2, and then 4 plus 1 inside the parentheses. Sometimes you guys might hear people say parentheses as quantity. Like, listen to me here. Negative 20 divided by bracket negative 2 times the quantity 4 plus 1. When you hear that, when you hear people say that, the quantity, that actually means parentheses. Or when you see that written, it actually means parentheses. So what should come first? Here, what should come first? Danielle. Parentheses. Right. So I write down our negative 20, not going to use that on this step. Our bracket's going to say negative 20, and then 4 plus 1 is 5. Now, there's two ways that you can write this. I could see you doing this, which is completely fine. But do I need those parentheses anymore? Is there anything inside those parentheses anymore, like any operation? No, it's just a 5, right? It's just a 5. What's the operation in between that negative 2 and the 5? Multiplication. So I am completely fine if you don't write those parentheses anymore because we completed everything on the inside of them. We can say, okay, negative 2 times 5. But by all means, if you want to keep the parentheses there, fine. Please use dots as multiplication symbol. Please do not use an X as a multiplication symbol because X this year will now mean a variable, not an operation. All right, we keep chugging away inside the grouping symbols. So Sid, right? Yeah, Sid, what do I do next?
Wait, what do you call this thing?
Bracket.
Okay, so you multiply negative 2 times 5, you get negative 10.
Good.
It looks like negative 20 divided by negative 10.
Good, yeah. Because do I need the bracket anymore? No, I don't need the bracket anymore. So it can go away. I performed the operation inside of it, so it can now go away. And then I take negative 20 divided by negative 10, and Danielle, right? Positive 2. Negative divided by a negative is a positive. Questions about that? Okay, so let's add on a step at the beginning of this. Let's say, okay, what if I have an expression and I've got a variable within my expression and I tell you the value of that variable? Like, for example, 10 minus x times 6 for x equals 3. 10 minus x times 6 for x equals 3. Evaluate the expression for the given value of x. So I have an expression, 10 minus x times 6, and then the given value of x is 3. Now, that's telling you that 3 is the value of x that I want you to compute here. There are going to be times where I give you an expression, and we change out the value of the variable. That's the definition of what a variable is, right? Something that varies, something that can change. So I'm going to say, okay, my expression is 10 minus x times 6, and I want to have you evaluate 3 or 4 different x values. Here, I'm telling you the one specific x value that it's going to be. So all you have to do when I give you an x value to plug into an expression is just take that number and put it in for x. 10 minus 3 times 6. Again, I know it seems tedious, but go ahead and take that step. Take that one additional second and write out that step with the value in there. Instead of 10 minus x times 6, say 10 minus 3 times 6. And now this is just like the problems on the other slide, right? What do I do first? What do I do first? Geo.
The multiplication 3 times 6 equals 18.
Good. I say 10 minus 18. And then what is 10 minus 18? Dom.
-8.
Negative 8. Very good. Good. Now again, this is the advantage of having your calculators. Make sure that you have your calculators in front of you because I'm pretty sure you guys don't want to do 10 minus, I don't know, 10 minus 18 is not too bad. But those tricky positives and negatives, they can get, sometimes our brains go a little haywire on those. So just have your calculator there for you. All right, we got 4 squared times the quantity. Be fancy. 4 squared times the quantity, x plus 3. Or you could read it as 4 squared times parentheses x plus 3. But the x value that I want you to compute is x equals -2. X equals -2. So I say 4 squared, parenthesis, -2 plus 3. And now I can start rolling. What do I do first? Griffin.
I would do the exponent first.
I would not, because there's a grouping symbol in that first. Right? There's a parenthesis first. So do the parenthesis first.
Are we distributing the formula?
I like what you bring up there because you see parentheses, and I know instinctually you guys are like, ooh, there's something on the outside of the parentheses. I want to bring it in, right? But can I actually do what's inside the parentheses? Yes. I can actually figure out what -2 plus 3 is. The distributive property is more for when I cannot do anything inside the parentheses. Like if there was like an x plus 3, and you can't add x and 3, right? Then at that point, yes, I would do the distributive property. But because I can actually take -2 plus 3, I want to do it first before I distribute. Does that make sense? Okay, so let's do that. -2 plus 3 first, inside there would then be a 1. And then I would take 4 squared to get my 16 times 1 would just be 16. You see how I just use those parentheses and that multiplication symbol interchangeably? You could do that. Okay, let's try our last one from this example. 14 plus x squared divided by 4 for x equals -2. Now, I want to talk a little bit about this before we start getting to it. I see a variable squared in the expression. I see 14 plus x squared divided by 4. Now, I want you to be very careful when you go to plug that in. Because when you go to plug that in, whenever you have a variable squared in our expression, whenever you go to plug something in, I want you to use parentheses. Especially when it's a negative. Especially when it's a negative. Here's what I mean by that. I see x equals -2, right? That's why I'm saying when it's a negative, when the variable ends up being a negative. So I say 14 plus -2 squared divided by 4. That's what I want it to look like. Because let me ask you this. I want everybody to do this in their calculators right now. Do -2 squared in your calculator. What do we get? -4. Now, do -2 with parentheses around it and then square it. Do you get something different? +4, you should. It should look like this. Oh, I got my negative first. Okay, the squared should go on the outside of the parentheses. Yeah, the squared should go on the outside. Maybe those of you who got -4 again, put it on the inside. But what's the difference between these two things? What is the difference? Well, if I take -2 and square it, the base of the exponent is just 2. Like I'm not squaring the negative that's sitting on the outside. So you're telling your calculator to do this. -2 times 2. The calculator's not doing it wrong. Calculator's doing it correctly. You're just telling it to put the negative out front, and a negative times a positive is a negative. when you put the parentheses in your calculator, you're telling the calculator, oh, okay, now the base of the exponent is -2. So that's what I repeatedly multiply. That's what I say, okay, -2 times -2. Negative times a negative. That's why it's becoming a positive. So when do you use what? Well, whenever you're plugging into an expression, when you're plugging in a negative value, you must put it into parentheses. When you're plugging in a negative value, you must put it into parentheses. This was an x, right? I have a negative value going in for x. I want -2 to be squared. To do that, I need to put it into parentheses. Okay? That's going to be a big sticking point a little bit later on. So now we have 14 plus +4 divided by 4. That should be your next step. Not -4, but +4. Hey.
I just have a question.
Yes, sir.
So for the exponents, do they just copy what the actual number is?
Yes, the base. Yeah. You take the base and it's like copy, paste, paste, paste.
Okay.
However many times the exponent is.
All right.
So if it was like 4 to the 10th power, I'd be taking 4 10 times.
Okay. All right.
Yeah. Okay, so yes, sir.
How do you know if it's to the power or if it's the square? Like, you know what I mean?
Yeah, so like if I had like 5 to the 7th power, that means I'm writing, should have picked something smaller, right? And then square is just it's just the power of 2.
Okay.
Does that make sense?
Yeah.
So it's still the same idea, it's just doing it twice over. That make sense?
Yeah. Oh, so like all twos are
Just multiplying it by itself one more time.
Isn't there like an actual squared symbol? Isn't it like a little?
Just a little 2.
Oh.
Like on your calculator, it's right there, like that x2.
Oh. Okay.
If you see that, that's squaring the number. So like 9 squared, oops, didn't do the 9. 9 squared is 81.
Okay.
Does that make sense?
Yeah. Thanks.
All right. Okay, so let's get back to this. What's the next step in this one here? I have 14 plus 4 divided by 4. Danielle.
4 divided by 4.
Which is what?
1.
Good. And we take 14 plus 1, which gets us our 15. Make sense? Okay, so let's talk a little bit more about those other grouping symbols. All right, we're on the back now. Let's talk a little bit more about those other grouping symbols. Those other grouping symbols that would be fraction bars, radical symbols, absolute value symbols. Those are all grouping symbols that we can use. Remember that fraction bars indicate division. I know this seems like really simple, like relatively easy, but I still see some people thinking like, oh, a fraction bar means something different. No. Fraction bar just means division code. Like that's all it means. Don't let it confuse you. It's just division. The only thing is you're dividing everything in the numerator divided by everything in the denominator. So you've got to take everything in the numerator, the top, done first, like complete the numerator. Take everything in the denominator, complete the denominator, like evaluate it all out, then divide. Like, so for example, let me get this out of here. So like 4 over 2, that's just 4 divided by 2, right? It seems really silly that we even write that. But that's what that means, right? Fraction bar indicates division. So what does an absolute value mean? Well, it means the distance away from 0. The distance can never be negative, okay? Distance can never be negative. You can move it to a negative direction. I'm not talking about direction. I say distance can never be negative. The value of distance can never be negative. Like, for example, if I'm sitting on 0, and like on a number line, if I'm sitting on 0 and I'm looking over toward like -10, how many steps do I have to take from 0 to get to -10? I'm going to take 10 steps, right? That distance is 10. I'm moving 10 units. That's absolute value, okay? So basically, mathematically, visually, what happens, all I have to do is just take off negative signs. The absolute value of a positive number stays positive. It's not like it turns it negative or anything. Don't do that. The only thing happens is when we have a negative inside the absolute value, it just chops off the negative side and turns it positive. So for example, a -4 inside an absolute value would turn into +4. Quite simply, just a -4 lops off the negative sign, turns it positive. And then here, if I've got an operation inside, you perform the operation. 2 minus 5 would be negative 3. And then I perform the absolute value on negative 3, and it will turn it into positive 3. Okay? Absolute value just takes distance away from 0, which means everything must always be positive in the end, coming out of it. So let's try some now. Now, when I have fraction bars, remember that it's just division, right? Just division. Why do math teachers wear glasses? Because it helps with division.
Wow.
I am so funny. I'm here all week, folks.
Don't get it.
All right.
Oh, I just got that.
Because it helps with division.
Oh, like the
I
vision.
was
The vision.
Yeah.
Okay.
All right, now I want to show you. Hey, do you guys like renewable energy?
Yeah.
I'm a big fan.
What's renewable?
That's what that same thing.
I still don't get
I don't know.
it.
I don't know how it's
Maybe one day I'll get it.
I'll explain it when you're older. All right. Now, when we have fraction bars, what am I doing now? I'm completing the top. I'm evaluating the top, and then I'm evaluating the bottom. I want to show you. Don't write this down. I want to show you what this is going to look like if I write it left to right. Here's what I mean. I would be taking 2 times negative 4 plus 22, and then I would be dividing it by 4 squared minus 9. But you may be thinking, well, you can't write it like that because in this case, that division is going to come before I finish the top, right? So what we have to do, if I wanted to write it like this, this is how it would look. And that's just messy to me, right? So, but that mathematically, that's what we're doing. We're treating all of the top as its own thing. We're treating all of the bottom as its own thing, putting them in parentheses, making them come before the division. Once we evaluate all of this, and once we evaluate all of that, that's when we do the division of the two things, okay? So maybe that helps you understand what we're doing. Now, let's actually go for the fraction bar. All right, let's go the top. Let's do the top. What should come first in the top, in the numerator? Nathan?
2 times negative 4,
Which is what?
negative 8.
So we have negative 8 red plus 22. Now, I can do the bottom simultaneously as the top. I can do it at the same time. So what do I do at the bottom? What's the first step of the bottom? We're just kind of doing 2 steps at once. Sid?
Change 4 squared to 16 minus 9.
Good. We keep going with the numerator. Negative 8 plus 22, that's 14. Keep going with the denominator. 16 minus 9 is 7. And then 14 divided by 7. Then at the very end, that's when we do the division. 14 divided by 7 is 2. 14 cutting it into 7 equal groups. There should be 2 in each group. Questions about that? Okay, let's do another one. Let's do an absolute value one. 3 absolute value 4 squared plus 8 divided by 2. 3 absolute value 4 squared plus 8 divided by 2. So I see the grouping symbol of the absolute value, so I've got to go inside that first. So in the 4 squared plus 8 divided by 2, what comes first? Do you have?
The exponent.
The exponent 4 squared to get us what?
60.
Good. 16 plus 8 divided by 2. Keep the absolute value symbol there. And also, folks, I've seen a lot of people get messy with their handwriting. Absolute values turn into parentheses, and that doesn't mean the same thing. So I take 3 absolute value 16 plus 8 divided by 2, and now keep going inside. 3 absolute value what? What should go inside the absolute value? Kyle.
16 plus 4.
16 plus 4. 8 divided by 2 is 4. Okay, which is 20. Now, does that absolute value really change anything at this point? No, because I've completed everything, I've evaluated everything inside the absolute value, and it's positive. And you know what? If it's positive, it's not going to change anything. So what's the operation in between the 3 and the 20?
Multiplication.
Multiplication, right? So I take 3 times 20 to get 60. Okay? And our last one for the day. Absolute value 4 minus 7 squared divided by -3. All right, absolute value 4 minus 7. Okay, I got to go inside the 4 minus 7, right? That's my first thing, because I go, where's my grouping symbols? I see the absolute value, I go inside there. 4 minus 7. What is 4 minus 7? -3, right? -3. -3, absolute value, -3 squared divided by -3. Now, what is the absolute value of -3? +3, right? That's when it turns to positive. +3 because of the absolute value. I square the 3. And now I perform the division.
You get -3?
Good. Now, I always have people struggle with this because you see, my answer is negative. Well, wait a second, there was an absolute value in the problem. True. But that absolute value was only acting on the 4 minus 7. It wasn't acting on the whole thing. So my answer, my solution can come out negative. That's okay. It's just, whatever I take the absolute value of, that's what turns positive. All right. So I hope we dusted off the cobwebs a little bit. Hope we got ourselves going a little bit. Got the bones moving a little bit. Everybody say bye to YouTube.
Bye, YouTube.